Alright, so we're going to go through this question here. The trick to this is called a combination circuit. So why do you think it's called a combination circuit? We've got two types of circuits, correct? We've got series and parallel. What has this got? Both, so we call it a combination circuit, correct? The trick to these is breaking them up into segments that make them more manageable. So any time that you've got a segment, you need to start small and work your way up. The first segment that I'm dealing with, is that a series or a parallel? Series, so I apply my series resistance R1 plus R2 equals RA. I'm calling RA that segment. I've made up A. I could call it whatever I want. Clear? I find that's got a resistance of 12. So now I can treat these two as one resistor. One resistor with a resistance of 12. Now I've essentially got one resistor here for RA and a resistor there. What type of series is that? Or what type of circuit's that, sorry? Parallel. Parallel. So I use my parallel resistance. So if this is the end of one segment, and now I'm finding my parallel resistance, I simply replace RA and R3 with the values for that resistor. I could replace RB with RT as well. What does RT stand for, do you think? Total resistance. Yep, so the total resistance, because that's the only resistor I have in there. Clear? So it'll be 1 on RT equals 1 on 12 plus 1 on 4. I now need to use my cross multiplication, or I could use common factor. Happy with that? What's 1 on 3? 1 on 12 plus 3 on 12? Oh, that's not it. 4 on 12. What do you think my next step is going to be? Yeah, I can. Oh yeah, I can make that 3. I wouldn't know in this case, but yeah, I can make that 3. I would make that 3, but I'm not going to do it because I'm going to show you something instead. No, it's not that confusing. RT's in the bottom, correct? So I've got to flip this side and flip the other side, so it becomes RT on 1, or just RT, equals 12 on 4. Now I simplify it. 12 on 4 is? RT equals 3 ohms. Clear? If you simplified first, you'd have 1 on 3, and then you flip it, you get 3 on 1. It's fine. Cool? I didn't cross multiply. I didn't, that's fine. If I'd cross multiply, I would have got 4 plus 12 over 48, which would be 16 on 48. Yeah. So I can use this now. Now that I find my total resistance, what's the question asking me to find? My current. My total current, correct? So I know V equals IR. I'm just going to put T's in here. Voltage total equals current total times resistance total. Do I know 2 of those things? Yep, so now I just rearrange to get I by itself. I equals V on R. I equals, what's my voltage? Over? I equals 4 amps. Now conceptually, and this is always a point where you can use some bit of common sense, is it possible for this resistance, this current, sorry, to be greater than my total current? What's the biggest value this branch could possibly ever equal? Let's think about our conceptual understanding of what circuit electricity is like. How did we get the analogy for circuit electricity? It's like a pipes, water. One of the videos. Have we watched that one? Water pipes. Does it make sense if we've got a branch in our pipes? Can we have more water running through the bottom track than entering the pipe system? So this must be less than the total amps. Does that make sense? So that's an indication that our value will be less than 4. What do you notice about the resistance? Let's just pull back and look at the resistance for the whole circuit. Is it bigger or smaller than every resistor on that? Smaller. How does that work? How is the resistance less than any individual resistor in that? Because in this, the total resistance was 12, correct?
Yep.
But in this one, I've got less. How does that work? When I've got a parallel, I get less resistance. How does that work? Let's say we had a fire evacuation. You all had to leave the room, right? But there's not 10 of you or 20 of you. There's 1,000 of you. Even if the window's open at the back, that's better. You'll get a few people at the back. That will increase the speed at which we leave the room, correct? So you will always have, in a parallel resistance, your total resistance will be less than each individual resistor. Clear? On the branch. Happy with that? How do we find out the bottom one? What type of circuit have we got?
Combination.
It's a combination. What's that bottom branch? Does any voltage get used up here, between here? Up? Any voltage there? Or not? No voltage, correct? So if you're an electron entering this wire, how many volts do you have? If you're an electron entering this wire, how many volts do you have?
12.
When you hit this point here, how many have you got left?
8. None.
None. Why has it got none?
Because there's 12.
It's got to use all its voltage, correct? And there's nothing between here and the end of the battery. So it's got to use it all in here, correct? And just like if you're an electron that enters this pathway, you've got to use all your voltage there across those two resistors. So tell me, what's the voltage being used across that? How many?
12.
12 volts, correct?
Yep.
Remember our voltage in parallel? I'm going to give you some rules after this because I think we're a little bit rusty on those. Our voltage in parallel, voltage equals VT equals V1, which equals V2. Going to be going through that again. 12 volts gets used there, correct?
Yep.
How many ohms?
4.
So what do we need? Do we know two of the three things?
Yeah.
V equals IR. I'm just going to, I'll call it I2 equals V2 divided by R. That should be R3. Doesn't matter. We'll make it threes just to be consistent. What's our voltage to the bottom again?
12 volts.
Over.
4.
Total current is? So 3 amps here. Does that make sense? Is it less than the total current? Is our current through that bottom branch less than the total current? What does that tell you about this current? What's it going to be? Have a guess. 1 amp, correct? Because if you're not entering the bottom path, you must be entering the top path. You can do the same thing there. What was the total resistance on that? 12. 12 divided by 12 is?
1.
1. Cool?